Alright, Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Azmi Zuddin Zaman, and my metric number is 215750. So today, being hired as the fixed team to analyze the crash of the VMEQ paying system. So for today, our goal for today is to demonstrate exactly why the original or the broken system failed due to high load and prove that our fixed new fixed system can handle the new high traffic. So first of all, the original system used multi-threading to handle queue numbers, payments, receipts, and notification sending. However, it suffered from three critical failures. One is race conditions. So the race conditions happens where the applications happens, especially in the queue numbers and the receipt IDs. Next is the loss updates, where the financial discrepancies happens where the final total collected amount is not the same as the amount of student being due or the amount of student being paying the system. And then lastly, is deadlocks, where multiple errors happens, where amount of users requested, high loads requests, high capacities, high traffic that looks happens where the system would freeze. Now, first, I would like to demonstrate each of those things happening. So let me just run the code. Okay, so this is our scripting. So I can run which version of the code that I want. So first of all, I'm going to run the broken code. And then I try to run, since I'm demonstrating in high capacity. So let me just show the low capacity first. So let's assuming we show the low capacity, and then we choose amount of threads to process the 50 requests. It should be fine. But when we try to process a high capacity, for example, a more than 100, let's say 110, for let's say 4 threads to process these amounts, we lost about 60. Only 68 has been processed, while the others, uh, 50, 42 has been lost. So as you can see, we lost in terms of payment because we actually can see the expected collection should be around 120,000, but we only received about 24,000 ringgit. As for the amount of queue, we're supposed to be 110 queues, but only 68 has been processed. So we can see that from this report scripting, we can see that we have failed for the payment check, the queue check, and the possible system might be broken. So let me show you what happens if we try to do it in high capacity, for example, even in high threads. So let me just run this again. Broken 610, 16 thread. See, we get closer to the actual queue number, but we're still having financial discrepancies, and the amount of queue being processed is still less than the actual amount. So let me show you guys the when the system is going to freeze. So let me just run it again. Let's say we're trying to process about 100 and about 1,000, let's say more than 1,000. Uh, and then if we try more than let's say 2,000 requests, and maybe I'll just put 5,000 amount. It's a relative amount. And then let's say 60 threads for it because we're having a lot of requests, so we're going to use a lot of threads. See, after we try to run it, the system would crash, and then it will not show us the reports or anything. It just stops at the thread 3 at student 1000. So it just stops uh, doing the thing that it's supposed to do, which is finishing the program. So let me just stop the program. So as you can see, program, the original program is problematic. It's not reliable. So as you can see, I want to show you where the problem lies first. For example, let me show you where is the original one. So this is where the original problem lies, is in the our thread implementation. As you can see, in thread worker.thread.java inside of the run method, this one, this run method, we have logic switch that based on what, for example, this ones, zeros and ones. So this zero and ones is in this case sort of methods. So we have case one, case two, case three, and case zero for queue, payment, receipts, and SMS. So from this code, we can see that for a low load under 100 requests, we force the system into the safe mode, which is mode zero. Hence, we added asynchronous blocks around the counters. This forces threads to wait their turns, hence technically fixing the issue, but slowing down performance. So since we're in the broken system in the file worker thread, so inside of the case zero for thread zero in this case, inside the sequential code, for the queue system, where is this? This one, the queue system is not very safe, where it would have a race condition problems, where let's say this thread want to access that thread, it would overwrite them. So we have a data leaks at that point. So as for it's the same case for the payment ones, the receipt and the SMS. So we have a lot of data leaks and a lot of race condition problems. All right, let me show you an example. So let's say I try to run it again. And let's again 110 requests for threads. So let's say we try to search for a number. Let's just receive 1019. Let's see. As you can see, we have received 1019 to student 72, and then 1019 to student 95, and then student 15. So it has been issued 3 times. So we have definitely have a race condition problem and data leaks problem. Let's say we try to search for Q30. Let's see, student 82, 81, and then 61. Same problems. Now let me demo for a high version. Sorry. Now let me demo you guys a fixed version for the system. So maybe just run this again. Okay. And then we try, let's say, it should work in, let's say, in 50s. See, lower loads should be fine. So 50, we got the same value. Let's try run. Try to run this again. I need high, sort of medium requests. Let's try 500. And then for rights, still not that much. We still get the value, but it still took a bit longer. If you're doing in higher threads, so it should run faster. So let's try to run this again. Let's try maybe let's say 1100. Let's try doing this thread instead. So as you can see, it runs a bit faster, and we got the result instantly. So as you can see, it runs stable. So let me just try to run this again. Let's say in higher, let's say 5,000 requests at a time, and maybe 16 threads. So as you can see, it runs a bit faster, and the system is stable. So all the check has been passed. So payment check passed, queue check is passed, and the overall system status is passed. As you can see, for 5,000, we collected about, so the expected and actual collection is correct. about 5 million. And then we have no crash or deadlocks behavior. So let me show you how or why how we make the system much more stable. So let me just go through the threading, how we do the threading. So for the process thread, okay, first of all, how do we fix the race condition problems? Is that we go to our queue data. So instead of just one queuing system like the original broken, where we have the single system for queuing for managing all the queues, all the data, and so on. We have a two classes for it. Two classes. We have manager, queue manager, for handling all the data, and then we to handle all the process of the data and managing the data. As for the queue data is where we put our data type. So we handle the value through the final through the atomic integers, atomic longs, and atomic integer and atomic long for handling our data operations. So as you can see, we use it for our queue numbers, the collected amount, and receive ID. Through this, we can ensure that we don't have any data leaks or race condition problems. All right, so let me show you what are the causes for the deadlocks behavior or system freeze. So if you look at the queue system class, we have a object for queue lock and payment lock. So these are the objects that causing the system to freeze. For example, let's say the thread zero wants to do the process for queue lock, and he needs to have clarification from the payment log. But then thread one, he wants to do the payment process, but then he has to wait. He needs clarification from the queue log itself. Therefore, we have a circular dependency. Hence, the system freezes where we have the one is dependent on other. Therefore, the system came into a halt. As for deadlocks, how we prevent that is that through pipeline automatizations. So we do pipeline architecture. So as you can see from the public void run, so this is we use the runnable for this one. And then this one is a thread, amount of thread we want to use. And then from this one, we have so as you can see, instead of using the like available queue number dot get increment dot plus plus plus, we have this expression to handle our queuing thread. Same for our payment, for our receiver generations and our SMS notifications. And then we have this one is for handling our parallel processing. So for example, I want to do 16 threads processing. It will do 16 threads. So it will run 16 threads of this threading from the queuing generation up until SMS notifications. So in summary, the broken system fell under high load because it relies on standard or primitive data operation, which is not thread safe, and it is lack a proper handoff mechanism for a split test mechanisms. For a fixed system, we succeeded by using the pipeline pattern, as shown now, to manage task flow and atomic variables to ensure data integrity. So we no longer have risk conditions or data leaks. Therefore, we have fulfilled all the requirements of this assignment. Hence, by reducing the problem, identifying the risk conditions, applying the correct synchronization, and implementing the producer consumer mechanism. So I think that is all from me. Thank you.